Okay, let's start with our next lesson this morning. We're going to do converting declination. And of course, declination is the difference in azimuth from a grid to magnetic, accounting on the various factors: curvature of the Earth, movement of the poles, um, and what it does is it gives us a different, when you have a grid azimuth that you measure with of course, a standard 1/50 map and a protractor, you'll get a grid azimuth, and there'll be a magnetic azimuth that differs from that. And that information, that what's called the declination, is always printed on the lower right corner of the map. And here it is on our specialty of voodoo map down here. And for our area in the state game lands here, Sandhills game lands, it's a 9.3 meter difference, or 9.3 degree difference, and that's listed right here, measured in 2017. And it tells you, it's printed right on the map, exactly what you have to do to convert it. So in this case, we're converting from magnetic to grid. You would subtract. If you're converting from grid to magnetic, you would add, and that's just written right here on the map. You never have to remember that. It's always written right there on the map. So just eases your cognitive load. So let's see what that looks like in reality. So let's take a measurement between, let's say we'll go from 6 points here all the way down to this intersection here between McDonald Church Road and Millstone Road, that intersection here. So we need to get the azimuth from here to here. So the way we do that is we take a straight edge. In this case, we'll just take a standard protractor here, and we'll use this straight edge on the protractor to line up here from this point down to McDonald Church. And the easy way to do it is take your pencil and put it on your start point, and then you can use that as a pivot point to rotate where you want to go, and then rotate that till it hits where you want it down here on this intersection. And then you're going to, holding that firm, you're going to draw that straight line out. You have to draw that line out far enough that when you place your protractor over the center, that line extends beyond the degrees on the edge of the protractor. So that's all we did there. So here's that line now drawn. 0.5 millimeter pencil is best. It's thick enough that you can see it, but not so thin that you can't see it, not so fat that it makes too thick of a line. So pencils generally come in 0.3, 0.5, and 0.7 millimeter. 0.5 is the one you want to go with. So now we have this line drawn here. We have to measure that. So we take that by taking our protractor, and the center here of the crosshairs is what we're going to measure. And that goes directly over our start point. And then we have to ensure that this protractor is aligned correctly with the map. So you can have it over that center point, and you can be shifted off slightly. So the temptation here is because there's this north-south road, that you would use that road to center your crosshairs on, but that would get you a couple of degrees off. If you notice up here, you can see where these east-west grid lines divert a little bit from the azimuth. So you sort of use all your senses here, and you're lining up with these north-south grid reference marks. So you just line that up. Let's see, I've got that right about where I want it. It's pretty accurate. Of course, this is always done best on a flat surface. So you probably don't want to do this sitting on your knee or huddled under a poncho, but sometimes in the field you got to make do. That's why there's always going to be a little bit of difference. And then that line, you can see that line real faintly right there, goes right underneath the 193 degree mark right here on the perimeter. So this is now becomes my grid azimuth. So my grid azimuth, let's do the math here. My grid azimuth is 193 degrees. And I know that if I want to go from grid to magnetic, I want to add. So my grid is 93, and my declination was 9.3 degrees. So 193 plus 9.3 is 102.3. So now when I enter that in on my compass, when I program my compass, I program 102 degrees, and that would give me that declination. So although, let's talk a little bit about, now we'll get do some advanced land navigation. Again, there's no such thing as advanced land navigation, but 9.3 degrees is pretty precise. And while that may be the correct answer, is always be as precise as you can. In this case, I'm going to say, what if we just make this 10 degrees. So we could do 9 degrees. That'd be obviously much closer, 0.7 closer. But just for ease of the math, if I just make this 10 degrees, then I can just get 103, and I can just have a nice even whole number, easy to use. And that's important because as we'll talk later about the compass only has so much innate accuracy to it. And your eye, if your eye and your legs can navigate a 0.3 difference, man, you're doing great for navigation. I want to make it easy. I just want to add 10, make it 103. I'm sorry, 203 rather, 203, and that gets me that gets me close enough. Now, so this way, this kind of eases my cognitive load a little bit. And if I'm going back and forth between grid and magnetic, and I'm doing various calculations, if I have a nice round number, especially like a 10, it makes that really easy to do. I've seen many candidates have. This has sort of been the failure for a lot. Is they will mess up even though it's written right on the map, whether they should add or subtract, and they'll end up, when they're going from grid to magnetic and they'll end up subtracting, they'll end up with 183. Man, you're in for a bad day. You're going to be way off target. So I like to ease it up a little bit here. I just go with the 10, makes it easy for the for all the calculations. But that is how you convert declination.